So, as I mentioned before, my name is Annie. I created my kind of sustainability website to showcase sustainable research as well as the barriers that prevent it from becoming industrial level. So, could you please kind of introduce yourself a little bit as well as your work, as well in your group's work at Stanford?
Sure. Thanks, Annie, for having me here. So my name is Matteo Cargnello. I'm an associate professor of chemical engineering at Stanford, in the Department of Chemical Engineering. And in short, I'm a chemist by training, and then I turn a chemical engineer. And what I do in my research group is to look into processes, chemical processes that would, on one side, reduce the energy needed in order to convert abundant chemicals into chemicals of interest, and on the other side also reduce emissions of CO2 and other harmful gases into the environment. So some projects in my group revolve around capturing CO2 from the atmosphere and from concentrated streams like flue gases, converting that CO2 into useful fuels and chemicals like ethanol, alcohols, and olefins like ethylene and propylene, or sustainable production of ammonia and hydrogen,
Mhm.
production of hydrogen with low carbon emissions, upcycling of plastics into useful fuels and chemicals. So in general, anything related to sustainable processes where catalytic materials are used in order to reduce the energy utilized in the conversion of these chemicals into other useful chemicals and in reducing greenhouse gas emissions in the atmosphere.
Yeah. So you mentioned about catalysis for kind of an audience that isn't very familiar with or doesn't have a chemical background. Um, what is catalysis and why is it important for creating these sustainable technologies or
Mhm.
kind of making these reactions go faster?
Sure. So yeah, so chemical reactions happen all around us. We're just not, many cases, not aware that that's happening. But some chemical reactions are harder than others. During chemical reactions, certain chemical bonds need to be broken and certain other chemical bonds need to be formed. And some chemical reactions to occur, they require, let's say, very harsh conditions. In some cases, we have temperature has to be increased by many thousands of degrees in order for those reactions to occur, or sometimes we have to add pressure in order to force basically these molecules to convert into others.
Hmm.
What a catalyst is a substance in general that would allow these reactions that are otherwise very challenging to occur at milder conditions. And
Hmm.
some of the best examples of catalysts are actually inside our bodies. These are called enzymes. Enzymes allow us to live and survive and break down molecules that we ingest or we breathe in and convert those into the building blocks of life, for example. At the same time, in industry, if we want to produce chemicals on a very large scale, we need this catalyst in order, again, to reduce the amount of energy that we have to introduce into the process and
Hmm.
basically to speed up, to accelerate the rate of this reaction in order to make it industrially feasible. So
Hmm.
what my group does is to look at materials. So these are solid materials that are called heterogeneous catalysts that would allow these reactions to go much faster than otherwise they would. So thus reducing the energy required to run those reactions and reducing the amount of greenhouse gases that are emitted during these processes. And
Hmm.
those are, catalysis is something that is industrially very widely applied. 90% of objects around us have been obtained through at least one catalytic step. So it's an incredibly important science and engineering topic that is used in order to, again, decrease the amount of energy, make things, chemical compounds more efficiently, and also allow for the large scale production of chemicals.
Hmm. What specific sustainability related problems is your group hoping to address, as well as how does your work kind of bridge a solution?
Mhm. Sure. Yeah. So there's Anything and everything that is related to chemical compounds that are relevant to large-scale processes is something that my group is interested in. So a few research areas that we work on is, for example, capturing CO2 from the atmosphere. So CO2 is a greenhouse gas that is known to cause the increase in the temperature of the planet for the last 150 years.
Hmm.
And there's too much CO2 in the atmosphere. If we were to decrease the amount of CO2 in the atmosphere, we could potentially, um, take back the clock and reduce global warming. So one idea is to grab this CO2 from the atmosphere because CO2 is quite an inert molecule. So figure out a way to grab this CO2 from the atmosphere. And then once we have this CO2, the idea is, can we use it for something useful?
Hmm.
And right now, for example, fossil fuels are, of course, powering the planet. And the most important aspect of fossil fuels is that they utilize carbon, hydrogen, and carbon-carbon bonds to then react with oxygen and release energy. So the idea is if we take CO2 and we convert them back into those like carbon-carbon and carbon-hydrogen bonds
Hmm.
in an economically feasible way, then we could utilize CO2 as a carbon precursor. So that's one topic that is of interest in my group, how to grab CO2 and how to convert it into gasoline that can power cars or other important chemical compounds that we use in large quantities on the planet. Other topics involve the sustainable production of hydrogen with low carbon emissions. Hydrogen is a very important chemical compound that is used for many different reasons, including the production of ammonia. Ammonia is the most important fertilizer that is really crucial in order to grow crops and allow the population to be fed, basically,
Hmm.
for food to be produced. So ammonia comes from hydrogen, and so we need a huge amount of hydrogen in order to make the large amount of ammonia that is used as fertilizer.
Hmm.
So but hydrogen production involves releasing greenhouse gases in the atmosphere. So in my group, we're also looking at ways to produce hydrogen without emitting carbon in the atmosphere.
Hmm.
So there are different ways that we are researching in order to do that. Another area is reusing waste materials. So we have projects related to taking discarded plastics, and because plastics are also carbon and hydrogen, then we want to turn those plastics into gasoline, potentially, or other useful compounds instead of taking carbon out of the ground. So all these projects related to reducing the amount of carbon that ends up in the atmosphere and reducing the amount of carbon that we have to take from the ground in the form of fossil fuels to produce chemicals and materials we need, that's a topic topics that are very interested and related to sustainability in my group.
Hmm.
Now, your question was also about bridging. Can you remind me of the second part
Yeah.
of your question?
How does your your group's work sort of bridge a solution to these problems?
Yeah, so there are clear problems that we know what the problems are. Then the question is how to find the right solutions. And because we are an academic group, we do quite some fundamental work. So our
Hmm.
work is definitely related to increasing the knowledge in the areas that I discussed. But then the idea is also to find true solutions. And so we also push our fundamental knowledge into the practical field of then finding solutions that can be applied to large scale into a large scale processes. And so at that point, that's where after we do the fundamental work, we ask ourselves, okay, now how can we scale this? How can we take this? How can we compare this with conventional technologies that are based on fossil fuels? And we do a little bit of that translational work that could potentially lead to starting companies or transferring the work to industry that then can take what we learn and convert it into devices, technologies, processes that can be applied at industrial scale.
Hmm. How does academia and industry work together for scaling up these technologies?
Well, it's not that they always work together, so it depends.
Yeah.
Some academic groups, including some of our products, are very fundamental. So things that we cannot envision will be implemented in industry for a long time or maybe ever. But that will certainly increase the overall knowledge in certain areas that could potentially lead to translational applications in the future.
Hmm.
Or sometimes they can be working absolutely together. So in our lab, we have projects that are funded by industrial partners that have, in many cases, a specific problem or challenge that they want to overcome. And we work with them to identify potential solution that could be translated to industry. So
Hmm.
what's What's the most wonderful part of the industry academia collaboration is that industry really provides for the very practical and important problems for academia to solve. And academia can provide the tools and skill sets and personnel, students and postdocs that can really tackle those challenging problems. So in most cases in my career, it's been a wonderful collaboration, and that always pushed me to think about the practical aspects of the research we do and do more and more of that practical work to translate our fundamental research into scalable solutions.
Hmm. So moving on to more scaling up, the aspect of scaling up, what are kind of the biggest challenges do you see as preventing scale up of sustainable technologies? Is it mostly economic or policy related, or maybe based on the scientific innovation itself?
Well, they're all related, right? Um,
Hmm.
in the sense that in most cases, it's, in my opinion, economics, right? We do have sustainable solutions for many of the problems, but they are not economically feasible.
Hmm.
And it's somewhat related to policy, right? There could be policies that could definitely help, but some policies cannot be implemented if the economics are just not good enough.
Hmm.
So let's say that we could make synthetic fuels that are derived from CO2 to replace gasoline that would limit CO2 emissions into the environment by, let's say, 100%, right? So you would completely replace fossil fuels with CO2. It's not realistic, but let's imagine that, right?
Hmm.
And let's imagine that the cost of the synthetic fuels will be, let's say, 1.5x or 2x more than the corresponding fossil fuels. Then potentially one could imagine a policy where the policy could force uh, people in some way or could provide incentives on the other side to adopt these sustainable technologies. And so at that point, the economics can help the policy. But if these synthetic fuels are 5 times more expensive, right? It's hard to imagine a policy that could be implemented that would not be hurtful to the economy, for example.
Hmm.
So that's why I see the economic side as being one of the biggest challenges for implementation of sustainable technologies, and that's
Yeah.
why scientists and engineers have to work harder and harder and together with policymakers in order to ensure that we get to that point in which sustainable technologies could be at least at the beginning incentivized and then later on hopefully supported even further in order to make this to increase the adoption of these technologies. But it's mostly economics, then
Hmm.
policy, and of course there are some areas where the technological advances are just not far enough, right?
Hmm.
Um, but in many areas of sustainable technologies, we do have technologies that work, it's just not at the right price.
Hmm. Then kind of looking ahead, maybe 10 to 20 years, what sustainable technology or research do you find the most promising or has the most potential?
Well, there's a lot of technologies that one could imagine be implemented in 10, 20 years. I don't know if I would say that I have an opinion on some that would be the most promising.
Hmm.
Maybe I would love to see some that are more advanced than others.
Hmm.
So let's put it that way. So uh, I'm very biased, but for example, technologies where we can use renewable clean electricity to
Hmm.
run industrial processes, so-called electrification of chemical processes, is something that I consider promising, and I would like to see more and more in the next 10 to 20 years. And so I
Yeah.
think it's both promising and important. And so the idea of expanding the generation of renewable electricity, which is already happening, solar panels, wind, and everything else,
Hmm.
is great, and continuing to do that, and then using that clean, renewable, carbon-free electricity more and more, including in chemical processes and industrial processes. That's something that I consider not just very promising, but something that is going to happen because of the cheap cost of renewable electricity.
Hmm.
So that's one. The next one that I would like to see is, again, very biased on my topics, but hydrogen. I would
Hmm.
hope that in 10 to 20 years, we figure out a way to produce hydrogen cleanly in large quantities with low or no carbon emissions, and in a way that then would allow us to use hydrogen to decarbonize very many different sectors, including the chemical sector,
Hmm.
potentially transportation as well. So hydrogen not vehicles necessarily, but hydrogen trucks, for example, that are hard to electrify. So anything that is hard to electrify would be great to do that in there. Hydrogen can also be used in order to produce sustainable aviation fuel. So I imagine in 10 to 20 years, probably having sustainable aviation fuels with much lower impact into the environment in terms of greenhouse gas emissions. I hope that's going to be very promising to the point of being deployed at a large scale in 10 to 20 years. And maybe one hope, but that's like the biggest dream, is that we could maybe achieve commercial fusion in 10 or 20 years, because that could unlock a lot of opportunities in the energy sector with huge consequences for emissions. So
Yeah.
maybe I'll leave you with those like four
Yeah.
ideas.
Hmm. And then last question for the interview. Is there anything that we didn't discuss today that you think is particularly important to know about the field of sustainability or particularly catalysis?
Well, I would like to say that in sustainability, a very, very important aspect is played by us
Hmm.
human beings, right?
Hmm.
So the attitude that we have towards our planet, towards the use of resources, towards reducing waste, and the mindset that we have all the new generations is incredibly important. So if we want to ensure that there's a future for this planet where our kids and the kids of our kids will live in a planet that is just as good, if not better, than what we have right now, is to change that mindset. So there is, of course, a huge component that science and technology and engineering can do, and policy can do, in order to give us a sustainable future, but there's also so much that we can do as human beings in changing our mindset around energy use, emissions, waste generation, that is probably just as important and as relevant to get to a sustainable future. So I would want to see more being done on that side.